Welcome to Geography in SQL Server Part 2. In Part 1, we looked at the geography data type and looked at the longitude and latitude for certain points on the map, including some of our favorite cities. In this module, we'll take more than 300 cities that are in a table. We will add a new column that will be of type geography. We will convert the latitude and longitude in separate columns into that geolocation, and then we'll calculate the distance from each city in the table to every other city in the table. Sounds exciting, right? Here in SQL Server, we are going to create a table called Utah Cities. We can see that we have attributes called city, state ID. Among other things, we have a latitude and a longitude, and those are both decimals. We don't have a geographic type in here yet. Also, when we look at the insert statement, we'll have to scroll across, and we'll see in this instance we have Stansbury Park. That's a city in Utah. It's in a specific county. And we have latitude and longitude. So we have all of these cities. So let's scroll up and execute the query. And we will let that execute and look at it. Here is the list of cities in this table. And you can see that we have the city name and the state, the county FIPS, county name, the latitude, the longitude, whether it's a point or a polygon, incorporated or not, the time zone, and the zip. So we have the table that's created then for Utah cities. The table Utah cities did not come with a geography column. So we do some code to add a column. It's going to be called geolocation, and it's of type geography. We will execute that, and we'll note that that table now has a geography data type column. So you see we have this geolocation column, but all the values are null because at this point we haven't added any of the latitude and longitude to it. The next step is to update the Utah cities table, and specifically the geolocation column. What we want to do is take the longitude column and the latitude column and put those into the new geolocation column that's actually of type geography. So we set geolocation equal to, and we have some nasty looking code here that specifies the two columns, the longitude column and the latitude column. Now we had to cast the longitude column into a varchar, and we had to cast the latitude column into a varchar, because this particular method converts text into a geographic data type. So it grabs the longitude and latitude and makes them text, and then converts it to geography. So we'll run this, and we now have data of a geographic data type in the geolocation for every row. Now, what does this 4326 mean? First, we look at the WGS84, which is an Earth-centered, Earth-fixed reference system, and it's based on a set of constants and model parameters that describes the Earth's size, shape, and gravity and geomagnetic fields. SRID stands for Spatial Reference Identifier. The most common spatial reference identifier in SQL Server is 4326, and that 4326 gives us distance in meters, which is what we want. Now there are a lot of other SRIDs, and you can query to find that, but 4326 is very common. The last time we looked at the data, we could see a longitude, a latitude, a state, but the geolocation column was null. Now we've populated the geolocation column, so it would be nice to look at it. Here's a query that'll do that. We'll select longitude, latitude, just so we can see those, and we'll cast the geolocation column to a string. Otherwise, it will look like gibberish. It'll look like hexadecimal output because it's an object. So we will cast that to a char. Let's execute this query. Pull up the output, and we'll notice that there's a longitude, a latitude, but those columns are of type decimal. The location is the geolocation column, and now we can see it, and it's a point. They're all going to be west and north, and we see the city name, then we see the state name. So now we know that we have a geolocation in the Utah cities table, and we could view it. So the next step will be to calculate distances from one city to another. The final task that we have left to do is to calculate the distance from each city in the Utah cities table to every other city in the Utah cities table. So we will go do a select and C1.city, C2.city. C1 is an alias for the first copy of the Utah cities table. C2 is the alias for the second copy. So we'll look at each of those cities, and then in the where clause we'll make it so that we don't see the distance from a city to itself. The next column that we want to look at is the distance from the location in C1 to the location in C2. We divide by 1609.344 because that again is how many meters there are in a mile. Here's our from clause. And notice that we have Utah cities as C1, Utah cities as C2, and we do a cross join. That means that we are going to take each row of the first copy of the table and concatenate that with every row in the second copy of the table. And the trick now is in our where clause. In our where clause, we know we don't want to see the distance from a city to itself. And so we might say, well, let's look at C1.city not equal to C2.city. But in that case, we get a lot of duplicates. For example, the distance from Salt Lake City to Provo is the same as Provo to Salt Lake City. So by doing the greater than symbol here, we will eliminate the times when a city such as Salt Lake City to Provo is seen again as Provo to Salt Lake City. Let's execute this query. Let's look at the answer. And notice that we see, for example, Adamsville to Abraham is 78.62 miles. Alpine to Abraham, Alpine to Adamsville, and so forth. So in this particular answer, we don't see any answers a city to itself, nor do we see an answer from a city to another city and then back again in reverse. So this was kind of fun because we could see the syntax that allows us to calculate distance. One interesting anecdote is that a student once asked me why the calculation was different, because she had noticed that it was about 20 miles more to visit her parents. And of course, this is a direct distance on the globe. The distance she was traveling was in a car, so those roads are almost never in a straight line, and thus the distances are different between driving and a straight line. Thank you.